Okay, everyone who has run away thinking this is a Cairo 1 workshop, it's not. It's about account abstraction. So kindly come back. Sorry. Cairo VM. Yeah, yeah. Sure. So I don't have a comparison. I mean, it's not a comparison, but it's a good slide. I can definitely. I'm happy to run through that. Oh, the question is the comparison between Cairo VM and ZK VM. So I'm gonna do that slide alone. Yeah, and this was a question that a few people asked me earlier as well. So basically, Starknet is not EVM compatible. So I think there might have been a bit of confusion when I did the earlier introduction saying that the verification happens on Ethereum, but that's a separate bit. So the Solidity contracts are deployed on Ethereum, which does the verification part. But Starknet itself, for its own logic, uses something called as Cairo VM. So it's not EVM compatible. And you might have seen a lot of EVM projects that are launching quite recently, like ZK Sync, Scroll, Polygon, ZK EVM, etc. So what is the difference between ZK EVMs and Cairo VM, right? And why did we choose to go with Cairo VM with Cairo as the programming language instead of using Solidity directly and using ZK EVMs, right? That's because Cairo VM is built keeping performance in mind, right? So zero knowledge proofs as a concept heavily use mathematics at the underlying. So if you have to produce proofs, you have to use the mathematics of that particular algorithm, whether it is Stark algorithms, whether it is Snark algorithm, or whatever other type of algorithms that you're using. You will have to build your programming language so that it supports that mathematics. So that is one reason why Cairo was created. And because Cairo is created to actually support this mathematics, the virtual machine that is built on top of Cairo or using Cairo is very highly performant, right? So it is anything that you run through using Cairo VM, it will be very easy to produce proofs. Whereas with ZK EVMs, the focus is more on compatibility. That means it is focused more on developer experience, right? Developers are already familiar with Solidity. So ZK EVM projects are built keeping in mind that there are a lot of developers who already know Solidity. So let's try to build something in a way which can also use ZK, but it may not be that highly performant. So the trade-off is between performance and developer acquisition here. For us, the higher importance thing, which is useful long term, right? If you want to run products, which is scalable products, you want million users, you want billion users. That means you want good performance, right? You want your products to be performant. That's why we chose to use Cairo VM and we chose to promote Cairo as the programming language instead of going the easy route of building ZK EVMs. And I'll show you one more slide if that is of interest, which is Vitalik ZK EVM classification. So if you see, many of the different projects that you might have heard of are classified under different types of ZK EVMs. So type 4, okay, let's start with type 1, which is fully compatible with EVM, that is Ethereum Virtual Machine. So this type of compatibility requires no changes to EVM, but from performance-wise, it will be very, very, very slow, right? So that's why you don't see any protocols that are fully compatible with EVM so far. There are lots of projects that are trying to reach type 2 compatibility, which might be the highest one that they could achieve as a trade-off between performance. The second type is where you change some data structures within EVM only for storage. which is also a high compatibility, but the performance again is very, very slow, right? And the third type, where you make some other small changes to EVM, which is some storage structures, some hashes. So right now, EVM uses different types of cryptographic hashes, right, for performing different things. There are hashes for digital signatures. There are hashes for creating blocks, etc. So you can change or tweak those hashes to suit the ZK algorithms, right? So this is one type of change. Pre-compiles are like binaries that support your program, some extra code that supports your existing product, right? Those are called pre-compiles, some binary. So the compatibility here is partial compatibility. So whatever projects that are there in the market right now are also not fully EVM compatible. They have partial EVM compatibility, and compared to other VMs, their performance is slow. And you can see a lot of popular projects like Scroll, Hermes, which is Polygon ZK EVM, ZK Sync. All of these are under type 3. We also have a project called Kakarot, which is built as a ZK EVM using Cairo. So that's also type 3, right? Now, the last type, which is a completely different VM, is what is Cairo, or which is what Starknet is using. So we use Cairo VM because the performance is very fast. And you can see that another project by Polygon called Maiden, it's called Polygon Maiden, and they're going to, I think, eventually rename it to whatever. They also use Starks, and they use another VM altogether because that VM will support the Stark algorithm. So there is a trade-off between adoption or between compatibility with EVM versus performance. And we have taken the performance route because that we believe is the best long-term. Like we are saying that Starknet is for scalability. But if your products are not performing up to par, then it is useless, right? Like it doesn't matter if thousands of users can use it or billions of users can use it if it is not good performing enough. So this is like the whole comparison between ZK EVM and Cairo VM. Okay. So, so my original talk was supposed to be a quick account abstraction theory slide and then a Cairo workshop of writing an account contract. But I feel like writing an account contract might be slightly overwhelming given the number of developers we have, and given that the learning curve for Cairo is a bit little higher than other programming languages. So I'm just going to run through very quickly Starknet native smart contracts accounts or smart contracts. So yeah, as you can see, I already gave this presentation a few days back on 12th of June. That's the same old date that I've kept, and I've just reused the slides. Yeah, that's pretty evident. I should have made that change. But yeah, I will finish this presentation very fast so you can get up and go have your tea, etc. But this is going to be an interesting presentation because I'm not just going to cover Starknet smart accounts, but I'll also cover what are smart accounts, right? In the next 3 to 6 months or 9 months, any conferences that you go to, you will definitely see a talk on account abstraction, okay? And whatever you need to learn about that, you'll probably learn in the next 20 minutes because it's actually quite simple, but it looks like it's quite complex. So why are people afraid of blockchain? Why don't we see so many products come on blockchain, right? And the reason is because people don't understand it, right? Any new technology that you see, there is always some level of resistance to learn that technology, especially if you don't see any products that look like user-friendly, like you go to a new country, you may install a Maps product or something like that. And then if you don't see that the map supports English, then it might be disappointing for you, right? You might just delete that app. So UX or an experience on a product is very, very important from a user perspective. And this is where account abstraction can come into picture. And this can be a huge game changer, to be honest. Like in today's agenda, we'll quickly cover account abstraction basics, a game changer, why it is a game changer. Not one, but two different implementations. It's not going to be highly technical, but it is to give you a context on how this all works under the hood, right? It's always nice to know how things work. And then some real-world application on Starknet. If we have time, I will cover that. So let's get started with account abstraction explain. So right now, when you think of Ethereum or most of the other layer ones that you might be familiar with, they use something called an externally owned account. Can any of you tell me what that means to you? What is an externally owned account? Okay, what do you do first time when you ever like want to trade crypto, buy crypto or anything like that? What do you do? Write a seed phrase? Okay. So you basically create a wallet for yourself, right? Like you create a wallet and you get an address, right? You get an address for yourself and you also get a very complicated seed phrase. So that is called, the seed phrase is something like a private key. Like how you have a password for your bank account, right? So you have a seed phrase that is a password for your wallet. If you lose that seed phrase or if somebody else gets hold of it, then your account is compromised and anybody can easily drain your account, right? So your externally owned account is controlled by a private key. And on Ethereum and most of the other blockchains, you need to sign the transaction from this externally owned account for that particular transaction to be successful, right? Otherwise, that transaction will not go through. For example, if Alice has to perform a transaction, Alice has to use her private key to sign that transaction, right? However, instead of an account like this, if you have a smart contract account, which means smart contract in this context is a program, right? This program cannot initiate transactions. So smart contracts on Ethereum cannot initiate transactions. But the advantage of that is that you can write any general logic as to how that account should work, right? We'll talk about what this general logic could be. But this is what it is right now on Ethereum, right? These are called smart contract accounts. So, of course, the user experience, like I mentioned with EOA, you have to write this seed phrase. I don't know whose 12-word seed phrase this is, but obviously they are super frustrated because it's annoying to, remember all of this. And, it's like you're hiding all your money because anybody can steal it. If you lose your seed phrase, what do, right? You lose all your money. There's no way you can hide it anywhere. And how does account abstraction help, right? How does it solve the problem? The first is that you can use different signature schemes. So right now, for Ethereum, it uses ECDSA, that is elliptic curve digital signature algorithm. And you can potentially use, and when quantum computers and all of that comes into picture, it is possible to break some of these existing signature schemes. So when you write your own smart contract, when you write your own program to create an account, right, which acts as an account, you have the ability to use different signature schemes. You can also pay fees with a different token. This is a huge, huge pain point right now with Ethereum. On Ethereum, you have to pay gas fees only with ETH, right? And if you receive hackathon money, for example, in USDT, USDC or something like that, or a friend decided to be super generous and gave you 1,000 USDC, Givuk, I'm looking at you. Okay, so how do you perform transactions, right? You can't. You have to convert part of it into ETH. It's a huge problem. You lose part of money in that, etc., etc. So you have to pay the fee. You can pay fees with a different token if you can use account abstraction. It also enables something called atomic multi-call. That means instead of performing multiple calls again and again and signing for all of that, you can sign for multiple transactions in one shot. So a simple example is Uniswap, right? Whenever you want to swap a new ERC20 on Uniswap, you have to first sign a transaction to approve that token, and then you sign a second transaction to actually do the swap. So you're calling two functions. However, in account abstraction, you can enable this natively. I will skip the replay attack. And The last thing is you can write any general logic as to how your account should function. For example, you can add social recovery algorithms, like if you lose your account key, can you recover that by logging in into Facebook, LinkedIn, Twitter, Gmail, etc. Right? So today we have a feature called Forgot Password on many of the email login platforms. You can create something similar using account abstraction by adding custom logic within your smart contract. And that is a game changer from a user experience perspective. Oh, that's the exact same slide now. Okay, so how is it game changer? Because this is a common practice for users to have social recovery accounts, etc. So the user experience is very Web2-like. You can enable multiple signers. Like for example, if it's a very sensitive transaction and there are 4 or 5 people in your business who need to approve that particular transaction, you can make sure that certain contracts or certain accounts have to come together to sign that transaction in order for it to succeed. You can enable that natively within your contract. You can do a lot of fraud detection. That is, today what happens is there are lots of scams, right? You can get some transaction on your MetaMask, you can sign it, and then suddenly you realize that, oh, like maybe this was not the right one, or suddenly some of your funds got drained, right? There was some script, maybe there was some attack on your browser or something like that. So instead of that, you can enable multi-level security, that your transaction goes to a server and that server can check whether this transaction is correct or not. And only if it is correct, then it will be proceeded further. And then this is a very, very cool use case, but very, very rarely talked about, is delegating session keys in gaming, right? Right now, the on-chain gaming experience for most Web3 games is extremely shitty, to be very honest. And largely in part because you have to keep signing your session keys after every couple of minutes to prove that it is you, your account, that is still involved in the game. Why is this important? Because only using your account, you can use the NFTs that you own to participate in the game. You can use the points that you own that are associated with your account to play the game. And imagine having to frequently keep signing, performing a transaction every time after a couple of minutes or couple of hours. So if you have a smart contract account, you can set up systems to automatically sign these and let your game keep continuing without you having to interrupt it. So you can enjoy your game without any worries by delegating the signing task to someone else for some time. And you can write the logic for this within your smart contract. So basically, when I said general logic, all of these different things are types of logic that you can embed within your smart contract account. And that's why it's pretty cool. And if we have better user experience, obviously there'll be wider adoption for account abstraction and in general Web3. Now, like I said, I'll be explaining 2 standards of account abstraction. The first one is EIP 4337, which was released by Ethereum. So EIPs, the full form of EIP is Ethereum Improvement Proposal. So this was proposed by the Ethereum community that let us have a standard to say how smart contract wallets will work. So this allows users to use smart contract wallets and to avoid having an EOA. The idea is to create more and more decentralization so that there is no central entity in the protocol, and all the people who use smart contract accounts will also get the same privileges as EOA users. And of course, there is no changes to the Ethereum consensus layer itself. That means at the protocol level, there are no changes. As an application developer, you will have to create your smart contracts. So how does it work, right? These are a bunch of users. Whenever they want to perform some operation, that operation goes into this structure called user operation mempool. So the EIP 4337 is defined as or smart contracts accounts with alternate mempool. This is what it means. That there is a separate mempool. What that is, I'm not going to go deeper into it. And then from there, a bunch of user operations are bundled together by the bundler, and it sends to something called as an entry point contract, which performs two operations. It validates if the transaction is correct, and if it is correct, then it will execute the transaction. Okay, I'm gonna skip. Okay, I'll quickly just give you a brief idea. Paymaster is another smart contract that can help you pay the gas fee in any other token or in any token of your choice. So what is the problem with EIP 4337, or what could be the potential attacks? The potential attacks for EIP 4337 could be that when the bundler simulates the validate function, the simulation may pass, but the actual transaction itself may fail, and because of that, bundler is under an attack called DOS attack, that is denial of service attack. The bundler will keep getting failed or invalid transactions from attackers, and because of that, it will keep performing some failed computation and it will never get paid for it. So this is where Starknet native smart contract account comes into picture. In Starknet, every account is a smart account. That means every account is a contract. Whenever you're going and creating an account on Starknet, what you're doing is you're by default deploying a new contract which acts as an account contract. So there is no concept of externally owned account in Starknet. And because of this, the signature can be a flexible field. Whenever you have a sender who's sending a transaction, the sender address will always be the account contract address. And now, here again, the account structure is going to be similar. Account contract structure is similarly taken from EIP 4337, which has a validate function, which verifies the account signature for any type of signature. And it has an execute function, which will call the function that needs to be executed. Okay, this is a very complicated diagram, so I'm going to skip through. Now, what are the differences between EIP 4337 and native smart accounts on Starknet? Because these are native smart accounts, some of the features are still under production, like fee abstraction and non-subtraction. But signature abstraction exists, right? Because the signature is coming from an account contract address. There is no bundler contract that is required, so there is no DOS attack. And here there is no financial risk as well. So in EIP 4337, the bundlers take the financial risk because they are going to bundle the set of operations and send it to the entry point contract. There is no legacy EOA, only smart contract accounts, and the cost is going to be very, very less. So because it's a smart contract account, every time you're triggering a transaction, it is equivalent to calling a function in an account for which you have to pay gas fees. In Ethereum, that gas fee can be extremely expensive. So, but on Starknet, because of the way Starknet works, because of the validity proof system, the gas fee is extremely, extremely reduced. So you can do any type of transactions using smart accounts on Starknet. Probably similar or even lesser gas fee than EOS, definitely lesser than EOS. So the summary for this and why account abstraction is important is because at a protocol layer, you can have a multi-signer. Multiple people can sign the transaction and it can be secure right from beginning. So you're not scammed, right? So this offers better security. You can have mobile signers as well. So that offers better. Something like a Netflix subscription on chain, right? You can just schedule recurring payments like how you schedule with your credit cards. You can write that logic within your contract that for this particular account, keep paying, keep giving recurring payments every month or something like that. And then right now there are lots of ideas that are being built on account abstraction, so you can definitely build something cool as well. Quickly, real world applications. I told you that I won't take much time, and seems like that side of the hall is starting to fill up more. So I'm gonna run through very quickly. Real world applications include Bravos and Argent, two popular wallets. Visa, which is the payment company, is also looking into smart contract accounts. So that means real-time applications like people who are experimenting with cryptography or blockchains are looking at smart contract accounts as one of the first things to gain entry into this ecosystem. So you can read about the Visa Starknet collaboration and what are they looking to build using smart contract accounts. Improved experience equal to adoption, and you can definitely try it on Starknet with the different wallets. So I'm gonna skip that, and last but not the least, lot of huge credits to my colleague Yael, who designed this entire set of slides. So huge credits to her. And yeah, thank you so much for staying for the last talk. And I hope you all learned some things, maybe a bunch of things about Starknet. And if you have any questions, feel free to reach out to me. My Twitter handle, unlike Yael's, is on the first page. So yeah, you can reach out to me over Telegram or anything. I'm happy to help. It's me right here. On Starknet, there is no normal account concept at all. Every contract is a smart contract account. You're saying what is the difference between a smart contract account versus another contract account, right? So right now there is no way to know the difference. But if you're able to see the contract code, you can see that smart contract accounts will have a macro called account contract versus normal contracts will have a macro called contract. So they will behave accordingly.